Okay class, we're about to start section 4.7 mixed numbers. We have section A, multiply and divide. All mixed numbers must be changed to improper fractions before you multiply or divide. Change the final answer back to a mixed number. Now, we go down here to example number 1. We have 2 1/5 times 3 4/7. Okay, first thing we need to do is change these mixed numbers to improper fractions. Now we remember, your denominators for the fraction stays the same. So this will remain a 5, this will remain a 7. Now to get our numerator, we take the integer times the denominator, 2 times 5 is 10, plus the numerator, which would make it 11. Now the same goes here, 3 times 7 is 21, plus 4 is 25. Now we multiply again. We will write the prime factorization of these numbers here. So we will have 11 times 25. Prime factorization is 5 times 5. And we know 5 is prime, and we also know 7 is prime. So these 5 simplify out, and that leaves us 55 over 7. Now remember, the directions told us, if we can, to change this back to a mixed number. So we would take 7 into 55. 7 goes into 5 0 times. 7 goes into 55 7 times. 7 times 7 is 49. And we subtract it. 55 minus 49 is 6. So we have a remainder of 6. Now, when we write our final answer, the first thing, all of the numbers that are in front of the remainder, that is the integer that you have. Now, your denominator stays the same, which is 7. Your numerator is all of the numbers or all of the digits you have behind the remainder, which happens to be 6 here. So your final answer is 7 6/7. Okay, now we go to problem number 2. We have division, and this is negative. A negative divided by a positive is negative. Now, all we have to do is remember that our final answer must be a negative. So now let's do this. We change this mixed number to an improper fraction. We put our denominator, which is 3 here. Now to get our numerator, 8 times 3 is 24, plus 1 is 25. And you can bring down your negative sign as well. Now we'll take that divided by, let's make this 5 over 1. Now we go down here. We will have negative 25 over 3. We keep our original fraction the same. Division becomes multiplication, and we take the reciprocal of 5 over 1, which is 1/5. Now we multiply. Now we take the prime factorization of 25, which is 5 times 5, and we'll put the negative out there. We do not have to write the 1 because there's no prime factorization of 1, and we know anything times the 1 is the number itself. And our denominator, both of the numbers are already prime, 3 and 5. Now we simplify out the common numbers, which is 5 here. So we have a negative 5/3. Now if we were just simplifying, we would be done, but the directions told us to change it to a mixed number if possible. So now this is what we would do. Let's disregard the negative sign for now and just take 3 into 5. 3 goes into 5 one time, and we will have a remainder of 2. Now, when we write our final answer, remember the integer, which happens to be 1 here, also must have this negative sign, so it'll be negative 1. Your denominator will stay the same, which is 3, and your numerator is all of the digits behind the remainder, and it just happens to be 2 here. So our final answer is a negative 1 2/3. Now we scroll down. We go here to section B. Now section B says add or subtract. It says change to improper fractions, perform the operation, and change back to mixed numbers. Now we could do that. Again, we keep our denominators the same. And now we get our numerators. 3 times 7 is 21, plus 5 is 26. Here we have 4 times 3 is 12, plus 2 is 14. Now, since we have denominators that are not the same, we need to find their prime factorization to get the least common denominator. So the denominators are 7 and 3, and both of these are prime. So to find our denominator, we'll multiply them. 7 times 3 is 21. Our denominators here is 21. Now we have to find our numerator. So we ask ourselves, we start with the 7 and compare it to 3. What does 3 have that 7 does not? We know it's 3. So we multiply this numerator and denominator by 3. Now we look at the 3 and compare it to 7. What does 7 have that 3 does not? And it's 7. So we'll multiply this numerator and denominator. It's supposed to be by 7. By 7 over 7. Okay, now, well, let me scratch this out and make that a 7. So it'll be 7 over 7. Now, 3 times 26 will give us 78. And 3 times 7, of course, gave us 21. 14 times 7 is actually 98. And 3 times 7, of course, is 21. So now we combine the like terms. We add them. Our denominator stays 21. 78 and 98 is 176. Now, we look at this problem here. We have 176 over 21, and we need to determine if we could factor out anything from either one of these. We cannot factor out anything from either one of these. However, it asks us here to change back to a mixed numbers. So, what we need to do here is take 21 into 176. Remember, whenever your numerator is larger than your denominator, you can get a mixed number out of that. So 21 into 176 goes 8 times. 8 times 21 is 168. 176 minus 168 leaves us 8. Because we'll borrow 1 from this 7, that will give us 6. And this 6 will become 16. 16 minus 8 is 8. And 6 minus 6 is 0. 1 minus 0 is 0. So we have a remainder of 8. So our final answer, our integer would be 8. Our denominator will remain 21. And our remainder, which would be our numerator, is 8. So it's 8 and 8 over 21. Now we go to number 2. Now first of all, we're going to make this 8 over 1. Minus, this denominator stays 4. And this numerator, 3 times 4 is 12, plus 3 is 15. Now we need to find a common denominator here. So we have 1 and 4. Now we know 1 does not have a prime factorization. Well, 4 prime factorization is 2 and 2. So we would just do 2 times 2, and that's 4. Our common denominator here would be 4. Now we ask ourselves, what does 4 have that 1 does not? It has 2 2's, which is really 4. So we'll multiply this numerator and denominator by 4. So we ask ourselves, what does 1 have that 4 does not? Which is 1. Now you can multiply this numerator and denominator by 1, but it will give you the same amount. So let's do that. 4 times 1 is 4. 4 times 8 is 32. 4 times 1 is 4, and 15 times 1 is 15. Now we can add them together. Subtract them. 32 minus 15 is 17 divided by 4. Now 17 and 4 has nothing in common. If we were just simplifying, we would be done. But we were asked to change this back to a mixed number. So now we take 4 into 17. 4 goes into 17 4 times. And 17 minus 16 is 1 with our remainder of 1. So our integer is 4. Our denominator stays 4. And our numerator is the remainder. And we're done. So that's 4 and 1/4. Now down here we have method 2. Now a lot of times I do not teach method 2, but I will just for the sake of this problem so you will have more than one way of doing it. Now if you're comfortable with method 1, you could just use method 1. But in order to do method 2, you must first write this vertically. So you have 9 and 8/15 minus 2 and 1/3. Now it says just work with the mixed numbers, meaning we need to change these fractions here. We have to find a common denominator of 15 and 3. So we have 15 and 3. 15 prime factorization is 3 times 5, and 3 is already prime. So we have one set of 3's in common, and we have a 5 left. So the common denominator is 15. So we put our equals here. This would be 9 minus 2. And the common denominator of both of these fractions would be 15. Now we ask ourselves with the first fraction here, what does 3 have that 15? What does 3 have that 15 does not? Doesn't have anything 15 does not. So this will remain 8/15. Now we go down here to the bottom fraction here. We ask ourselves, what does 15 have that 3 does not? We notice it has a 5. So we'll multiply this numerator and denominator by 5. 1 times 5 is 5, and 3 times 5 is 15. Now this is a little stray mark here, so don't worry about that. That was just a little error. But let's subtract these fractions. 8/15 minus 5/15 will give you 3/15. And then 9 minus 2 is 7. So we have 7 and 3/15. Now if we could simplify this, we need to simplify it. So this is what we need to do. We'll put equals. Remember, this is just a straight mark. So then we'll have 7. Then our numerator would be 3, and our denominator would be 3 times 5. Because we'll take the prime factorization of the denominator. These 3 simplify out, and your final answer would be 7 and 1/5. And that's it. Now we go on to number 2. Number 2, again, we have to line these up vertically. Now we need to find the prime factorization of these denominators so we can find a common denominator. This would be 3 times 3, and 4 would be 2 times 2. So they have nothing in common, so it'll be all of these prime factors, which will give us 36. So the common denominator of these two fractions is 36, but we carry over the whole numbers. So the common denominator would be 36. Now we ask ourselves, we're comparing the 9 with the 4. We look at the 9, then we look at the 4. We ask ourselves, what does 4 have that 9 does not? It has 2 2's, but we know 2 times 2 is 4, so we will multiply this numerator and denominator by 4. 2 times 4 is 8, and 9 times 4 is 36. Now we go down to here to this 4. We ask ourselves from the 4, what does 9 have that 4 does not? And we notice 9 has 2 3's, which is 9. So we multiply this numerator and denominator by 9. By 9/9. 1 times 9 is 9, and 4 times 9 is 36. So now we add them together. 8/36 plus 9/36 is 17/36. And 4 plus 6 is 10. And that's it for that problem. Now we scroll on to the next page. Now again, we line this up vertically. We have 3 5/7 plus 4 2/3. Now, with our prime factorization of the 7 and the 3, both of those are prime. So we multiply them together, and our common denominator would be 21. So we would have here 3, and then the 21 for the denominator, 4, and the 21 for the denominator. So we ask ourselves, what does 3 have that 7 does not? And that's 3. So we'll multiply the top and bottom by 3. And that would give us 5 times 3 is 15, 7 times 3 is 21. We ask ourselves with the 3, what does 7 have that 3 does not? And that's 7. So we'll multiply our numerator and denominator by 7. So we will have 2 times 7 is 14, and 3 times 7 is 21. And we'll put our addition sign.